In this lesson, we'll find the integral of x squared divided by x to the sixth plus 5 using substitution. This requires us to identify an appropriate substitution to simplify the integral. A good substitution simplifies the integral significantly. In this case, let's substitute u for x to the sixth plus 5, the term in the denominator. When performing substitution, we need to replace every x with u in the integral. To start, we'll convert dx to do. We do this by differentiating our u substitution. The derivative of x to the sixth plus 5 with respect to x is 6x to the fifth. Next, we solve for dx. We rearrange as 1/6 x to the fifth do equals dx. Substituting back, we need to include this term in our integral. Additionally, we still need to replace x squared. Recall we previously defined u as x to the sixth plus 5. We can relate x squared directly. If we solve for x squared in terms of u, x squared equals u5 to the power of a third. Now we can substitute completely in terms of u and do. The new integral becomes the integral of u minus 5 to the power of a third times do divided by 6x to the fifth. Recall we previously defined u as x to the sixth plus 5. We can relate x squared directly. If we solve for x squared in terms of u, x squared equals u5 to the power of a third, so we can express the integral only in terms of u. Now we can substitute completely in terms of u and do. The integral becomes the integral of u5 to the power of 1/3 divided by 6 times u5 do. We're ready to integrate in terms of u. The integral of u minus 5 to the power of a third is 2/3 times u5 to the power of 4/3 plus our constant. Our final step